Now, before actually studying the process of armature reaction, first we have to understand certain important terminologies. Once you have command or grip over these terminologies, then the understanding part of the armature reaction will become a very easy part. And when you talk about competitive exam point of view, and these important terms only constitute most of your MCQs. Therefore, it is very important that you study them very carefully. So the first term I am going to take is called as field axis. So what do you mean by axis in general? Axis in general exists for any physical object. Let us say there is a water bottle over here. Now this water bottle also has got some axis. Now I am asking you, what would be the axis of this fellow, this water bottle? So basically when you say axis, axis is simply a line formed by joining the dots. Which dots? The center points of the object. For this object also there will be some center point. Where will be the center point? Inside. Inside there will be a center point. If you join all those center points, then you will get the axis. So axis for this bottle will be a straight line like this, passing through the center of the bottle. Understood? So like that, axis is basically some imaginary line. So I will define field axis as the line. It is an imaginary line which represents the direction of magnetic field. So basically I can tell the axis, field axis is nothing but it is some axis which actually passes through the center of the magnetic flux, and it is directed along the direction of magnetic flux. So that is called as the field axis. For example, let us say I will take a bar magnet with a north to south direction, something like this. So bar magnet, north and south direction. Now how will be the direction of magnetic flux along this bar magnet? As you know, flux starts at the north pole and goes back to the south pole. So the flux emanates from here and the flux joins back at the south pole. Here also flux goes out of the north pole, and flux joins or flux returns back at the south pole. Understood? So this will be the direction of magnetic flux around the bar magnet. Now if I am asking you what will be the direction of this particular magnetic system, means the direction of north pole, means in which direction it is going. It is going like this. It is going like this, and it is joining back to this south pole, or if there is any other south pole, it will go and join there like that. So what would be the axis of this fellow? So this axis, I can tell this is the axis. So axis of this particular magnetic field is along the north pole. Always north pole represents the direction of magnetic flux. Similarly, here also you will be having some magnetic field. So for the main pole. So that thing we will see as we will move forward. So I hope you understood what is the magnetic field direction means. Direction along the north pole. Okay. Right. Now the next definition is polar axis. So polar axis is nothing but, if you define them, the axis or an imaginary line which joins the centers of the pole again. So let us say here are two poles, north pole and south pole, and every pole has got its own centers. Now if you join the centers of that particular poles, then what you are going to get is called as the polar axis. For example, let us say this is the center of this pole, center of this pole. Now I am joining with a line. I am joining the centers of this center points with a line. This is that line. Now this line is called as what? Polar axis. And another thing to note is this polar axis also called as d-axis. It's also having another name called as d-axis. So you can write it down here. So this becomes the first point, and the second point is also called as d-axis, where d means direct axis. Okay, direct axis, it's also called as d-axis or direct axis. And another point regarding polar axis is that position of this polar axis, whether it is fixed or does it change. Do you think the polar axis position will change always? Now here you got a vertical line over here. Do you think it will change? Definitely. Once if you have brought a DC machine, are you going to change the positions of the poles? No. If the position of the pole is going to change, then the polar axis is going to change. Why? Because polar axis depends upon the position of the poles. It is the line passing through the poles. But basically, if you buy a practically generator, you don't open it and you don't change the shape of the poles or the position of the poles, because they are fixed to the yoke. So polar axis, the direction of polar axis or this axis depends upon the construction, and it is fixed because the construction is not destroyed always, it is always fixed. So I can tell the position is fixed. Okay, the position of polar axis is fixed, and because it depends upon the construction. Next, GNA, geometric neutral axis. So basically I can tell geometric neutral axis can be any axis which is perpendicular to the polar axis, which is perpendicular to the polar axis. If it is perpendicular to polar axis, if I am supposed to draw that line, how will it look like? GNA. So GNA will look something like this, isn't it? This is going to be the GNA. And in other words, I can define it in other ways also. I can tell that axis or an imaginary line that passes through the midway between the poles. Midway between the poles, you are passing a line, an imaginary line, that is also GNA, geometric neutral axis. And I told another point that it is always what? Perpendicular to polar axis. So I will write down, it is always perpendicular, or we can say in quadrature. Quadrature means 90 degrees, or in 90 degrees with polar axis. So after this 90 degrees, please leave some space because I am going to write something else. And when you talk about the position, do you think it is a fixed position? Yes, position is fixed. Why? Because I told you that it is some line which is 90 degrees to the polar axis, and if polar axis changes, then GNA will also change. But polar axis is not going to change because it depends on the construction, and GNA position also fixed, it also doesn't change with the any other factor because it also depends on the construction. So another important point that you can write down here is another name for GNA. GNA also called as, it is quadrature axis, hence it is called as Q axis. Okay, Q axis, or another name is, it is also called as interpolar axis. Why it is called interpolar axis? Because it is the line along which the interpoles for a DC machine are placed. So this is very important point for competitive exams, right? So I told you that the position is fixed. All right, now this is for a two pole case. This is the diagram for polar axis and GNA, Q axis. Now let me take a four pole case. Four pole case we will take, and I will see. So four pole case means 4 poles you require. Okay, 4 poles are there. 4 poles means like this is north, south and south. Understood? Like this. Now if I am supposed to draw the polar axis for this case, what will be the polar axis? Polar axis would be, you will get one polar axis for one pair of poles. Let us say direct axis 1, D1, another polar axis D2. Now what about GNA? Sir, you told that GNA is something which is 90 degrees or perpendicular to the polar axis. Now if I take polar axis 1, for this polar axis 1, what would be the 90 degrees line? This would be the 90 degrees line, but there is already another D axis. Now for this one, if you take 90 degrees, this would be the 90 degrees. Then I am not able to draw the quadrature axis for this 4 pole system based on this definition of 90 degrees. Whereas let me take the first definition. First, what I told you, the axis that passes through the midway between the poles, I told you. If I wish to use that definition, then I will get the polar axis. Yes, I will get the quadrature axis. The line passing through the midway between the poles. I am getting or not? Yes, I am getting. Let us say this is quadrature axis 1, Q1. This is Q2. Okay. Now, then what about this statement? I am telling it is 90 degrees, but if I am seeing here for a 4 pole system, how many degrees I am getting here? 45 degrees only. How can we justify? You see, this 90 degrees quadrature perpendicular which I am telling is not just mechanical degrees, but it is 90 degrees electrical degrees. How can you say electrical degrees? See, you already know the difference between the physical mechanical degrees and electrical degrees, that electrical degrees is equal to P by 2 into mechanical degrees. Now here mechanically how many degrees is there between the D axis and Q axis? 45 degrees is there. And how many pole system it is? 4 pole system into 45 degrees. If you do this, what I am going to get? 90 degrees. Is it not? Yes. So it is actually the 90 degrees displacement between the direct axis and Q axis. Whereas here it was a two-pole system. For a two-pole system, D axis, Q axis are displaced by 90 degrees mechanical and electrical, because for a two-pole system, theta E is equal to theta M, that is electrical degrees is equal to mechanical degrees. Understood? So this is going to be the information about GNA. Now let us look at the magnetic neutral axis also. So magnetic neutral axis, what do you mean by magnetic neutral axis? See, as you can see what is written over here, it is the axis along which the induced EMF is 0. Like you have already studied that while studying the operation or the working of DC machine, we have seen that whenever the conductor is moving parallelly to the lines of force, magnetic lines of force, at that position the conductor induced EMF was 0. That means when the flux cutting angle is equal to 0, when the conductor is moving parallel to the magnetic flux. So from that observation we have already known that here at these both points the induced EMF would be 0 and maximum induced EMF would be at these centers of the poles, isn't it? Now if I am supposed to join these 0 EMF points, means the point where there no EMF would be there induced in the conductor is called as MNA, magnetic neutral axis. Now what's special about this MNA is that it is not fixed like the GNA or polar axis. Okay, the position, okay, the position is not fixed. But what if not fixed? It varies depending on load. How much load is there? Based on that it will keep on varying. Now you see, here is the catch. It depends on what? Load. If it is depending on load, if load is there, what is going to come? Armature reaction is going to come. So then I can tell the shifting of MNA, because the position is not fixed. I am telling that the position varies. Varies means the position shifts. The MNA shift is associated with what? Loading of the machine, which is nothing but armature reaction. So the reason for changing of MNA is what? Armature reaction. So this is the effect of armature reaction, that MNA position is not fixed, it changes. And this MNA fellow also called as what it is also called as? It's called as commutating axis. It's also called as commutating axis or commutation axis. Otherwise it's also called as brush axis. It's also called as brush axis. Why? Because the brushes where you place is generally along the MNA, and the purpose of placing brush on the commutator is for facilitating the commutation. Therefore we say that commutation takes place along the MNA. But here there is another discrepancy, but is that generally we find that GNA is also called as brush axis. Why is it so? So there are two things associated with this. Ideally speaking, brushes are to be placed at the places where the EMF induced will be 0, where the EMF is induced to be 0. But in the normal cases, let us say a no load condition here, like given here how many fluxes are there? Only one main flux is there. I still did not take the existence of load or armature conductors over here. So under no load condition, what is happening? GNA, MNA both are coinciding with each other. That also becomes a very important point. Let me write down. At no load, GNA, MNA coincide with each other. Okay, the position is overlapping over each other. So at this point of time, if you are placing brushes, then it is fine. Now after you load it, the position of the MNA will shift. Let us say it will change, something like that. Then the 0 EMF points will also be shifted, and under that condition, if you are going to place brushes there only, like some sparking at the brushes is going to take place. What you have to do to avoid that sparking? You have to shift the brushes also along with the MNA. Hence we say that a brushes must be placed along MNA. But practically, do we do this? No, practically we don't do this. Even though the MNA shifts on loading, the brush position is not changed. It is always placed along the GNA. So it depends upon the question. In the question, if he says that ideally brushes are placed along which axis, it should be placed along MNA axis, because at the MNA 0 EMF must be there. So this is the brush axis. Ideally I am telling ideally. But practically, where do you place the brushes? Practically we place the brushes along the GNA. So you can write here also. Practically brushes are placed here. Okay, practically brushes placed along GNA. So you have to look in the question whether it is given practically or ideally, theoretically, something like that. But if nothing such mention is there, ideally or theoretically or something like that, brushes are placed along, put MNA as the answer. That will become the answer, because this is one of the most confusing part for many students. Therefore, I have thought to clear it right now. Okay, so the position of MNA is not fixed at the same time, and it is the axis along which the brushes are placed. Ideally, brushes are supposed to be placed, hence it is called as that brush axis. And another point is that this MNA which is there, its position is always perpendicular to what is called as field axis. This is always perpendicular to field axis, magnetic field axis. So here there's something fishy, you see. That means, sir, you told that MNA is not fixed and it depends upon the load. That means its position is changed due to armature reaction. Then do you also say that field axis is also not fixed position and it also changes with load and armature reaction? Yes. What did I told you in the earlier? I told you that due to armature reaction, one effect was cross magnetizing effect. In cross magnetization, what you are doing? You are changing the distribution or the shape of the magnetic flux. You are changing the shape of magnetic flux means whose? You are changing the magnetic flux of the main flux, main field, or the main field which is present in the system due to which the EMFs are induced. So this field axis represents the axis of the main field, and axis of the main field, of course, due to cross magnetizing effect, it will change. And if the axis of the main field will change, automatically who will change? MNA will change. So MNA is attributed to which effect of armature reaction? Cross magnetizing effect. Due to cross magnetizing effect, what happens? Field axis changes. If field axis changes, to the perpendicular always is whom? MNA. So MNA will also change. So this is the about MNA. Okay. So apart from these axes and all, there is some other definition, that is pole tips. Write down, there is another terminology called as pole tips. Fifth one, pole, P-O-L-E, pole, T-I-P-S, pole tips. So in these pole tips, basically there are two types of pole tips. What do you mean by tip of the pole? So if you see, this is the pole, this edge itself is the tip, isn't it? Yes. So how many tips are there? Tips, how many tips? How many tips are there? So you have LPT. LPT means what? Leading pole tip. PT means pole tip. So leading pole tip. LPT means leading pole tip. And next there will be another pole tip, TPT. PT means same pole tip. T means trailing pole tip. Leading pole tip and trailing pole tip. So let me show you what is leading pole tip or trailing pole tip. Before that, I will dictate the definition of leading pole tip and trailing pole tip. Please write down. Leading pole tip means the pole tip where the conductor enters into the magnetic region under the pole. Trailing pole tip, the pole tip where the conductor leaves the magnetic region under the pole. Okay, so that is LPT and TPT. Now if you see here, let us say I am telling that this armature is rotating clockwise direction like this. Now if there is a conductor here, now if this conductor is entering into the magnetic pole tip, magnetic region at this pole tip, so I am calling this is LPT, and here the conductor leaves the magnetic region, isn't it? So it is called as TPT. Likewise here at the south pole, both the terminology will change. Now here the conductor is entering, now this becomes LPT and this becomes TPT. Understood? So LPT, TPT, this concept you have to understand. Now there is a twist over here. Now I have assumed that the conductor or the armature rotating in clockwise direction. What if I am supposed to rotate in anti-clockwise direction? Now this TPT is no more a TPT. Now this will become LPT and that LPT will become TPT. Understood? So the position of LPT or TPT depends upon what? The direction of rotation. So you can add another point here. The positions of LPT and TPT depends upon the direction of rotation of the machine. So another fact you have to understand is that for generator and motor to have the same conditions, for same conditions in a generator and motor, the direction of rotation will be different. If generator rotating in clockwise, then motor has to be rotated in anti-clockwise for same condition. So same condition essentially means the direction of current. So you can write another point. For same conditions, the direction of rotation of generator is opposite to that of the direction of rotation of motor. So hence we can tell when you are operating this machine as a generator, let us say you are rotating in clockwise direction, then you got LPT, TPT, so on like this. Suppose if you want to operate the same machine as motor, then you are supposed to rotate it in what? Anti-clockwise, then the LPT, TPT positions will change. So this fact you have to keep in mind. So up to now this many concepts are enough for understanding the armature reaction. In the next video, we will understand how the armature reaction phenomena actually occurs, and then subsequent concepts we will deal. Thank you for watching.